And so we have Candace Wilhelm, who has come here. She was actually serving this same role at West Virginia University, and she kind of had a connection through her husband here at CW. Her husband came over and is Associate Vice Chancellor of International Affairs. And Candace, we were able to leverage her and get her over into our office. So I wanted to bring her over and put a face to a name, because you'll start getting some emails from Candace, and I'll allow her to introduce herself too.
Good evening, everyone. As Dr. Porter said, my name is Candace Wilhelm, and I just moved here a week ago, so I'm newer than most of you all, but I'm from West Virginia, and am excited to be here. So any way we can help, our office can help, feel free to reach out to me.
And since we haven't had an enormous amount of communication, if you do have any questions, I'll be happy to answer anything.
About the MBA program, or about your whatever, future?
Well, future, you guys,
what to be when we grow up.
I will tell you something kind of interesting, in case you're wondering, but we did go through this past fall a review of our MBA program, and we've moved towards having 3 credit-hour classes rather than 2 credit-hour classes. So in the future, students will be taking, instead of 8 credit hours per semester, they're going to be taking 9 credit hours a semester, instead of taking 3 credit-hour classes. And that's one of the main differences between what you guys came in under versus what the new class will be coming in under. It'll take the same amount of time to graduate. There will be a Learning Alliance project just like you have, but there'll be some difference in the core classes that they take. And a lot of this was done because, and here's the other part, we're going to be introducing a completely online version, or almost completely online version of our MBA program to kind of keep up with some of the MBA programs that are around the state. So there's some cool new developments that we're going to have. You're going to be the last group that goes through with the 2 credit-hour classes. But our goal, it's going to be a lot of the same professors who are teaching in it, a lot of the same classes. They'll just kind of take some of these classes that you might have had 2 credit-hour classes, kind of combine them down, and maybe some of those classes that were just 2 credit hours might get enriched a little bit. So there'll be 30 credit hours of core and some specialization in Learning Alliance. So anyway, that's the first news that we've announced to the MBA program, but you might have heard a little bit in the works. Okay.
All right. Well, thank you. I'll just turn this off. Thanks.
Thank you.
Yeah. Bye, guys. Okay. I thought it was one more class, but I guess this is it. Okay. Tonight I'm going to be doing a lot more of the theoretical stuff. So those of you that took finance in college, this should be kind of a smashed version of what you might have studied in your investments class in college. I understand that you're MBA students, so you're not in the business of plugging numbers into formulas and all that, but I personally feel like you should know the formulas behind things and understand where the why people are doing what they're doing, even if you have a machine that's going to do the calculation for you. So I just want you to understand the theory, like this concept of diversification. This is a very intuitive idea, the idea that you don't put all your eggs in one basket. Everybody kind of knows that in general. Well, it's actually math-based. There's a real numbers reason why we diversify. And there's only so much benefit to it. You can you benefit up to a certain number of stocks. And after that, adding more different stuff doesn't really do any further benefit to you because you've taken advantage of all the benefit there is. So that's all of that is sort of numbers-based, and that's what I would like to be able to introduce tonight and most likely in the next class as well. I can't imagine I can get through this in one night. So that's where we're going. You'll see the formulas are already on a formula sheet. Your assignment was just to introduce you to the concept, but I feel like I need to see the whites of your eyes when I'm going through this stuff because I need to see where people are able to follow me and where they're not. So rather than everybody flipping the classroom where they put the lecture online and put the activities in the class, I've flipped it back. And I've put the activity online, and I've put more of the lecture in class. That way you are free to ask me questions, and we can I can kind of tell where I'm losing you. And if I need to, I can sort of shorten something and move on to something else. So the concept is how to choose assets for your portfolio. This is what we're kind of going for. How to build an investment portfolio. And let me just define a couple things. A portfolio is just any collection, right? It's any collection of investments, and we use the word assets. So you can have a portfolio with one stock. You can have a portfolio with stocks and bonds. You can have a portfolio of 500 stocks. That one portfolio, we usually call it a risky portfolio because it is comprised of risky assets. There's some degree of risk to everything that's in that portfolio. That's a risky portfolio. There's also a risk-free asset out there, theoretically anyway. There is a risk-free asset out there. So theory says that there is a way for you to save money risk-free. You're investing in the risk-free asset. And there's a way for you to borrow money risk-free, theoretically. In real life, that's not necessarily true. The rate at which you borrow and the rate at which you lend are not the same. But theoretically, that rate is the same. And you can, we don't really know what the risk-free asset is, but we use different instruments as a proxy, like as a, the best we can. So some people will use the U.S. Treasury bill. Some people will use the repo rate. Some people might use the 2-year Treasury note. They might use the government rate on some other maturity. So all different researchers use various things to proxy for this risk-free rate. I'll just give it to you, but in your actual project, you're going to have to go download some numbers and calculate a risk-free rate for yourself because you'll need to do this. I keep looking up because I feel like it's dark in here. Is it? It's not. It's just me. I'm just feeling like it's dark. Okay, so here's the idea. Hi, Sunil.
Hi.
Nice to see you. When you're building a portfolio, so you're building an investment, a collection of investments, there's the idea is that you can try to, he's not up there, he's right here. You can try to build that portfolio by picking individual stocks. That's called security selection. And there's a famous investor out there, Charlie Ellis, who calls that the loser's game. So you are picking individual investments, and the best you can do is not lose as much as somebody else might lose. Right? So if you think about a sports analogy, I should never use sports analogies because I don't actually know anything about sports. But from what I've read, you can win a game 2 ways. One, you can not play as badly as somebody else. And the other is to actually play better than somebody else. So you can win by playing a winner's game, or you can win playing a loser's game. Right? So there is the idea out there that by picking individual stocks, you're playing the loser's game. The best you can do is just not as bad as somebody else might be doing. The other way, the winner's game, according to Charlie Ellis, is that you choose broad asset categories. So you make a decision on, say, 70% stocks and 30% bonds, or 70, 20, and 10% cash. That's called asset allocation. And he says that is more of the winner's game, that making those bigger decisions is more profitable than trying to guess what the next big stock is going to be. Right? That's kind of the idea here. So security selection is one way to do it. That's picking individual stocks and bonds. And according to this one investor, and he's written a lot, that would often be called the loser's game. Whereas asset allocation, where you're choosing broad categories of stock of investments, so maybe large cap, small cap, bonds, cash. So you're choosing to allocate across asset classes, might be called the winner's game. So that's kind of where we're at right now. And this whole unit is talking about asset allocation. How do we create this portfolio? What kind of thought needs to go into creating this portfolio? So first, let me define a couple things. If I say something about a risk-return trade-off, that should make some sense, right? Higher risk should you will want more return if you are taking on more risk. You're going to want you'll be willing to accept less return if it's less risky. So if I try to plot something like that, I might put return here, and I might put risk here, and I should say that some investment A, offers this level of return, this level of risk, and I haven't defined what the units are yet. And I would look at this investment B that has maybe the same level return, higher risk. In that case, I would say that A dominates B. Right? A dominates B. Every rational investor would choose it. This is that traditional finance that you read about in the last, or you saw in the movie. The rational investor would look at the return and say, same return, lower risk, A dominates. So A is the winner here. And that same investor might look at B and C and say, okay, wait, for the same level of risk, I can get more return. So C dominates B. But between A and C, I can't really tell. That's inconclusive. Higher return, higher risk, lower return, lower risk. I can't tell between A and C, but I can tell that A dominates B and C dominates B. So I already know that this is not a good portfolio for anybody that's rational. Nobody would look at that and say, yeah, that's the portfolio I want. So that takes that one out of the running. So it may exist, but no one's going to buy it. No one's going to want it. So now let's define these axes. The return. We look at return as the expected return next period. What should I expect next period? We never look at the stock price. We always look at the percent change in the stock price. That's return. Right? So what should I expect next period? And then risk. We're going to define it different ways. For now, we're going to look at risk as the variance of those returns, sigma squared, the variance of those returns. So expected return is my reward. And I'm going to say the variance of that return is my risk. And it's, in fact, the total risk. And now how do we calculate that? You personally, if someone came to you, and you're a broker of some sort, and your client came to you and said, what return should I expect on this stock next period? How would you answer that question? What would you look to?
Historical performance and average.
You might just go back over history and pick out the average and say that's a pretty good guess for next period. That's one way to do it. Right? And we know that the average is your best bet anyway, because you could have picked historical returns and just picked the number that happened the most often. So you could look back over the last 40 years and say, most often it returned 12%. My best guess, Mr. Customer, is 12%. That would be a reasonable expected return, right? But you've just picked the mode. Right? So you can go through all the statistics. You can take the range, and you could say dead center, and of course you just pick the median. And if the returns are normally distributed, this is your stat, your mean, the median, and the mode are all the same number anyway. So it's a reasonable guess. What's another way of finding an expected return? You could just come up with your own expectations. Like you could just
make it up.
You can make it up. Right? You can make it up. You can. You can try to be a little more scientific about it.
Sounds like a bad broker, though. I don't want to go to him.
I'm trying to think of an idea that was good, but
So I don't think you pull it out of a hat, but you can try to. You could say
Ponzi scheme to me.
or that.
hey, you got 100 good stuff over here. I got the best deal.
Do I have a deal for you? So what you could say is maybe over the last 40 years, whenever the economy was in a recession, this type of stock earned negative 12%. And whenever the economy was booming, this stock earned a plus 40%. And then you might say, there's a 30% chance of a boom and a 70% chance of a recession. Let me average those two numbers and say, here's my expectation. That's called scenario analysis. People do it all the time. That's just scenario analysis. So you could just say, well, I'm going to give every one of those previous returns equal weight. That was the average that you just did. Or I could say, no, I'm going to give these more weight than others because they're more likely. That's the scenario analysis. I'm just using probability weighting. So there's your old college math coming into play in finance. So when a broker shows you their analyst department's expectations, they arrived at them somehow. They came up with those numbers somehow. Either they used history or they just, made them up. Right? Okay, so we can calculate an expected return. And then we can say, well, how volatile is that? Because if it's expected at 12% next period, what's the probability of hitting 12% next period? Oh, statisticians in the room.
Standard deviation.
No, the probability of being dead on your expectation next period.
Good.
It's not good. In fact, it's 0. Right? If you remember, like in a continuous distribution, the probability of any one number is actually 0. You need the probability of a range. So we do that. We'll say, how about one standard deviation around the mean? And that's, 60, I always want to say 64 or 68.
67,
yeah, 67 point something, right? Or we could say, well, how about 2 standard deviations around the mean? Now I can assign a probability to that, and that's whatever, 94%, right? Or 3 standard deviations, there's 99%. So I can, if that 99% or that 94% is a really huge range, that's a pretty risky stock. If it's a pretty narrow range, that's a much safer stock. Safer as in we should get what we expected. Not safer as in you could lose money. It's just safer as in it should be about what we expected. There's less noise around it. Okay, so now we all know how to calculate this. You can do it for any stock you want. Right? In Excel, equals AVERAGE, right? Equals average. There's your expectation. Equals VAR, open parentheses, and the number. There's your total. There's your variance. There's your total risk. And some people use variance and some people use standard deviation to denote total risk because variance is a unit that's kind of weird. It's a squared unit. The number, it doesn't make sense to everybody. So we often take the square root of the variance. Now it puts it in numbers that make some sense to us. But they tell you the same thing. It's like talking feet versus inches, right? They're still telling you the same thing. Okay, so we have, so this is like a basic idea in finance. Now the next basic idea in finance. So this is number 1. That is this risk-return trade-off. What dominates? What's the winning portfolio? Okay, we got that. Second big concept is this notion of risk aversion. So let me mark this as number 1. Let me mark this as number 2. And that's this notion of risk aversion. Okay. Okay. So now I'm going to use my my return and my risk as my axes now. And now the risk aversion, which is the rational traditional finance concept that we came across before, says this. An investor who was satisfied with, let's call it portfolio A. Well, no, I want to put the A over here. In order for them to take on one more unit of risk, they're going to require some more unit of reward. So this particular investor, in order for them to take on more risk, they're going to require more reward. But in order for them to take on yet another unit of risk, same thing, they're going to require more reward and then some. Every additional unit of risk requires more and more and more reward. Okay? So this is the diminishing marginal utility. Every additional unit of risk, more reward, another unit of risk, more reward, and then some. That's my scientific way of saying this. Okay. So this investor would be equally happy between A, or this reward and risk trade-off, B, or this reward and risk trade-off, C. In fact, they would be indifferent between A or B or C. We call this an indifference curve. Do you remember that from econ way back when? But it's ringing a bell. I've heard that before somewhere. I don't know that they even teach indifference curves so much in econ anymore. But this is the theory that the behavioral finance people are poking holes at. They're saying, how on earth can you plot this? Like, who actually can do this? That's the problem with this theory. Okay, but still, we'll at least know it, so we'll be well educated. So you're indifferent. So an investor who was offered A would have been indifferent between A, B, or C. That same investor, had they been offered portfolio X, would be indifferent between X and Y and Z. So if A was all that was available to them, they would have been happy with A, B, or C. Any of those were fine. If they could have gotten X, they would definitely take X, but they would be just as happy with X or Y or Z. So whatever one is most available to them that's in that direction that dominates, we can identify that investor's risk aversion, their utility, their indifference curve. So X is definitely going to dominate A. So if they can get their hands on X, they're going to take it. Right? If we can find a better one up here, they'll take that too. They're going to choose the portfolio on the highest indifference curve that's available to them. So someone who is very, very risk averse, and someone else who is less risk averse. So here we go with the me oversharing. I'm probably more risk tolerant than maybe my husband. Just in terms of maybe financial decisions or that sort of thing. I probably can tolerate more ambiguity in my life than he might tolerate. And even some of the people I work with. Will my indifference curve be steeper or flatter?
Flatter.
Well, I guess you had a 50-50 chance of being right, didn't you? The more compensation I need for an additional unit of risk, makes it actually steeper if I'm more risk averse. So yeah, so I'm more tolerant. Mine's going to be flatter. Is that what you were answering? Your answer. Yes. Okay. Yeah, so the more tolerant you are, the flatter your curve. The more risk averse you are, the steeper your curve, because you need more compensation for that additional unit of risk. Okay, so somebody else might be like that, right? That person is just more risk tolerant. They're less risk averse. So now, back to this. We already know that A dominates B. We know that C dominates B. We don't know about A or C. It's going to depend on your indifference curve. Which of those falls on your highest of your indifference curves? So someone with generally a fairly flat set of indifference curves that go like this, C wins. Right? They'll choose C. Someone with a steeper, someone who's more risk averse, A wins. A wins. The person who really can't handle risk, A is going to be the winning portfolio. The person who can tolerate more risk, has a higher indifference, flatter indifference curve, will choose C. Okay, so now basic theories in finance again. Okay, so we understand there's a risk-return trade-off. We understand which portfolios are going to dominate the other. We understand that your risk aversion drives your choices, and when it comes down to portfolios that we can't eyeball anymore, it depends on how risk tolerant you happen to be. So some people will buy C, some people will buy A. That's where we're at. We're working our way, if I can kind of show you the forest for the trees, I'm working my way into an argument where at the end of the day, all of us are going to choose the same one. That's where I'm getting to, which has led to the explosion of the mutual fund industry. So at the moment, we don't all choose the same one, but theories have expanded. So I'm taking you on a little finance journey to where we ultimately get to the point where no matter what our risk aversion, we will all ultimately choose the same portfolio. We'll call that the optimal risky portfolio. And it basically comes down to a lot of people buying some version of the S&P 500. It's actually played itself out off of the stuff I'm talking about on the board. So that was a little sneak peek of where I'm going to end. I'm not there yet. This is where I'm headed. So at the moment, without knowing anything else, some people choose this, some people choose that, different levels of demand for different levels of assets. It's going to be difficult to figure out what something's worth because we all have different demands for different assets, but we're getting there. Okay, so this is just if I chose a portfolio or an asset in isolation. The next thing I want to do is I want to introduce this concept of allocating my money between a risky portfolio and a risk-free asset. So some of my money in one of those and some of my money in a risk-free asset. So let me do that next. Okay, so I'm going to start with the asset allocation. And what I'm saying is I'm going to put some proportion of my money, and that proportion we're going to call it Y. So for example, if I put 70% of my money in the stock market, Y equals 0.7. Okay? And that would mean that the rest of my money, is
mattress.
in the mattress, which is the risk-free asset. That's risk-free, R sub F, risk-free asset. So that would mean 1 minus 0.7 is 0.3. So 30% of my money in the risk-free asset. So I've just allocated my money. I've just made an asset allocation. And I can identify what the expected return of my portfolio will be. There are some sample problems that are online for you. So I'm going to come down here so we can just keep working our way across the board. So these are the sample problems that are available under whatever, I think chapters 6, 7, 9. It's on the last one. And I'm looking at problem number 1A. So you're considering investing in a risky portfolio and risk-free T-bills. The risky portfolio has an expected return of 15%. Let me give that letters. The expected return of my risky portfolio. I'm writing and talking at the same time, so you don't know what I'm saying, I'm sure. The expected return, and I use the subscript P to indicate that it's a risky portfolio, is equal to, what did I just say, 15%. And the standard deviation of that portfolio is 20%. And if you have a computer and you want to pull it up on Blackboard in front of you, you're welcome to. The solutions are there as well. So if you're not writing fast enough, don't worry about it. So you're considering investing in this, and the risk-free asset can currently earn you 5%. So my risk-free rate is 5%. Of course, we know what that is. The standard deviation has got to be 0 because it's risk-free. Right? So that goes without saying. It's a risk-free asset. So I don't need to actually put that on the board. It was risk-free. So if I invest 60% of my money in the risky portfolio, the remainder in T-bills, then what is the expected return and standard deviation of my total portfolio, my complete portfolio? So Y, in this case, is 60%, which means that the rest, 1 minus Y, is 40%. So I'm investing 60% in the risky portfolio, the remainder in T-bills, then what is the expected return and standard deviation of my total portfolio? This is a very simple averaging kind of problem. The expected return of the whole thing, and a whole thing, I want to call it the complete portfolio. So I'm going to use the subscript C for complete, is going to be Y times the risky one plus 1 minus Y times the risk-free asset. So it's just an average of the two, right? 60%. So if 60% of my money can earn 15%, and the other 40% of my money can earn 5%, then I can expect 11%. And now how about risk? Well, if only 60% of my money faces risk, then I'm facing 60% of that risk. I mean, I could write the rest out, but it's 1 minus Y times 0. Right. If I did that. Because the rest of it's 0. There is no risk. So we've got 60% of my portfolio will face a volatility of 20%. So there's the volatility of my portfolio. I should expect a volatility of about 12%. So in finance, by the way, people use those words interchangeably. Volatility, standard deviation, they use those words interchangeably. They typically do not use volatility to mean beta. They almost always use it to mean standard deviation. All right, so I have here a risk-reward trade-off of some sort. Let's plot a couple of these numbers. Oops. So expected return, so my reward and my risk. I have a couple of points that are on the board there right now. I know that for a 0 level of risk, I have 5% return. There's the risk-free asset, right? That was the risk-free rate. That's what that one was. I know that a 15% return corresponds to a 20%. This is not to scale. This was the P. So if I had put 100% of my money in the risky asset and not put any money in the risk-free asset, I should expect 15% return and a 20% volatility. If I had put 100% of my money in the risk under the mattress, I should expect 5% return and no risk. But here, what we did was 60-40. So if I put 60% of my money in P, I should expect 11%, and volatility was 12%. There's a nice little risk-reward trade-off. And you can choose on there how much to shift your assets. So most people have some money in cash and some money in a risky asset. Most people don't park all their money right here. Most people don't necessarily put all their money right here. They do shift it a little bit. And as you get closer and closer and closer to retirement, you start shifting that way, right? You start shifting your asset portfolio away from maybe the risky stuff and towards the safety. So right here, y was 1. 1 minus y was 0. Here was the complete portfolio. Here, y was 60%. 1 minus y was 40%. And here, this was the risky. So y would have been 0. 1 minus y was 1. That was right there, right? So all I did was shift my weights. Can I do this? Can I choose to invest right there? I'll give it some fake name. Can I invest in portfolio X?
Be a riskier portfolio, but more return. So yes.
Yes. How would I do it? What do I have to do to get out there? I mean, if I put 100% of my money in P, how am I going to get out to that part of that trade-off?
Increase your expected return.
It would increase your expected return, but how do you physically get your hands on portfolio
Borrow
X?
money.
You have to borrow money. You're going to have to do it on margin. Right? You're going to have to leverage. So here, yeah, you can do this. This would mean y is 1.2, let's say. 1 minus y, negative 0.2. You need to borrow 20% so that you can put 120% in your portfolio. Hedge funds do it. Right? Hedge funds do that. They go long and short. In fact, they're called long-short funds. Mutual funds don't. They're called long only.
What, 1,000 hedge funds went broke last year?
What was that?
1,000 hedge funds went broke last year?
So maybe not
Or
being
some-
out there isn't
or
such a great
something,
idea.
Right.
Yeah. Yep. That's what you do, right? You close it down, start a new one. Is that how it works?
They do.
Don't keep a record of your losses. You're fine.
Just close down.
Yeah.
Build a new house. Yeah.
Call Bernie Madoff.
Yep. Just move on. So this is kind of a typical trade-off. If I had this one risky portfolio and I can choose to put some of my money in a risk-free asset, I can do this. This line is called a capital allocation line. Or CAL, capital allocation line. And we just did that. We just drew it. Can you find the slope of that line? Do you remember how to find a slope? Do you remember your rise over your run?
Rise over run.
Who here has kids in, in elementary school right now? Where do they do this? In middle school about? If your kids are that old, you're doing it at home too. So you can find the slope here. Rise over the run, right? You can pick any 2 points. It wouldn't have mattered which two. So we might as well take these two, this one and that one. We could have taken the other one. The rise over the run. So this would be my rise. This would be my run. So I could have 0.11 minus 0.05 divided by 0.12 minus 0. I get 0.5. That's the slope. I get the slope. If I had picked this slope right here, I would have done what? I would have done 0.15 minus 0.05 divided by 0.2 over minus 0, right? It wouldn't have mattered because it's a straight line. Either way, you're supposed to get the same slope. This slope has a name. We call it the reward to risk ratio. It's the reward to risk ratio. And it is a ratio of your reward that's over and above the risk-free rate per unit of risk. It's the reward that's above the risk-free rate. We call that reward a risk premium. So you might hear that like thrown around in financial press. That numerator is called the risk premium. So let me write that over here. It's the expected return of whatever portfolio, either the complete one, C, or the full one. It didn't matter which one, but it was some portfolio that had risk in it, minus the risk-free rate over the standard deviation. That is the reward to risk ratio, right? That's the slope that I just used. And that numerator is it's called the risk premium. And this is the risk. So that reward is called a risk premium. So one of the surveys I get all the time is, what do you think the risk premium in the market is right now? And if you ask a lot of academics, we were stuck in the old days where we thought risk premiums were, 8% or like these big numbers, which they haven't been for a long time. And then you ask practitioners, what's the risk premium? And you get like way smaller numbers. It would be something like 4% or 6% or something. So it's just, what do you expect to earn over and above the risk-free rate? And many people will estimate that and then make a lot of financial decisions based on that. So I know that it sounds like it's all theoretical. It's really stuff that in maybe larger institutions, people are trying to estimate properly.
Wasn't that one of the objections to MPT was that risk premium was always kind of thought of to be 5%, I thought, and I can't remember who wrote the article. He said it's actually all over the map.
It is all over the map. It is. So depending on what you estimate it could make quite a bit of difference in your investment decisions because it might affect what you allocate to which portfolio. but people use it. And they try to refine it and try and be right. So there's the theory that I'm showing you, and then people complain about the theory because they say, well, you can't hardly put it into practice because we can't get numbers for some of these things. That's the argument against the theory, but people still use it, right? And so I think what you'll walk away from in this semester is that you'll see for every idea, there's a counter idea, and you'll find one investment group doing this, and then you'll find somebody else doing exactly the opposite, and it's on you to figure out which one you're most comfortable with. So here's this risk premium. Here's our unit of risk. There's our capital allocation line. We can shift back and forth across that line, and people do as their needs change. So in the last unit, I think you had read a little bit about investment policy statements. In an investment policy statement, the investor might tell the financial planner or financial advisor, I need to be able to generate 6% expected return over the next whatever many years. But I am not willing to accept risk. Well, this is what says you can't do that. If you need to have a specific level, if you want 6%, here's how much you have to put in the market in order to get there. And here's the level of risk that goes along with that. Endowment funds and foundations go through this all the time because they have to generate a certain amount of return to be able to pay for scholarships and whatever, right? So markets come what may, they still need to be able to generate a certain amount of return. Well, so when they plot their kind of risk-reward trade-off, they're determining how much of the fund goes into which assets so that they can at least try to expect a certain level of expected return. So that's kind of the practical application of something that seems relatively simple here. But remember, how did we come up with our expected returns? We had to either use historical numbers or we had to figure them out, like some kind of scenario analysis. So it's not like it's as clear as all that. Okay, so we can shift Y, right? We can shift Y. This was assuming that this was expected portfolio P. What if I had a different portfolio available to me? Maybe this one. And I look at them just on a clean slate. Actually, let me move Q, because this one makes it pretty simple to figure out. What if Q was there, and what if P was here? And I can make it even more tricky if we just move P right here. Remember how I said you can't quite tell? Without looking at the risk-free rate, you can't quite tell which of those dominates. You'd need your indifference curves, which nobody really knows exactly how to draw them, but theoretically, if you had your indifference curves, you could figure it out. Well, if you introduce this concept of shifting money between the risk-free asset and your portfolio, and this was the only asset available to me, I could have put 100% here, I could have put 100% there, I could have done 60-40, and I could have done this, right? That was the capital allocation line I just drew. But what if there was another portfolio that was up here somewhere? And I could do the same thing. I can put some of my money in the portfolio. I can put all of my money in the risk-free asset, or some split, 60-40. That's a straight line. Now, if I was happy with this one right here, the 60-40, that would have gotten me 11 and, what was it there, 12? I could actually do this. something higher. It would have been a different split. It might be like 30-70 or something in a different portfolio. So now what would I choose? Well, this dominates that. This is my fancy finance terminology. This combination of Q and the risk-free asset dominates P and the risk-free asset. I can find a way to get to the same level of risk and have more reward. I can do that. So I would look through the universe of stocks available to me. And if I was satisfied with this, I'll pick the stock that gives me the highest, the steepest capital allocation line, the highest reward to risk ratio. I'll look for the stock out there that gives me the highest reward to risk ratio. I'll look for it. And then all I actually have to do then is shift Y. I can shift Y and achieve better and better reward for the same level of risk. So I can find a way to maximize my expected return for a given level of risk. That would be the most rational thing. That would be rational. Would be for me to look at all the possibilities. S&P 500, Dow Jones, a stock with a couple of family stocks in it, a portfolio with this. I'd look at all the different possibilities out there, and I'm going to pick the one that offers me the highest reward to risk ratio. I'll find that one. And then I'll decide, well, how much money do I actually want to put in it? I could put all my money in it. I could put some of my money in it. I could put more than all of my money in it. I could borrow money and put it in it. I just have to find that portfolio. So what we want to do next is find that portfolio. I want to find that combination that's going to give me the highest reward to risk ratio. Okay, so next. Are you with me so far? I feel like I have to keep apologizing to the finance people in here because this has got to be. Do you have a finance degree too? No? I know you do. You do. But you worked in it. Right? Okay. So there's some in here that you can help me teach this, but okay. So I am looking for the portfolio. I'm looking for that combo. How do I find it? That's what I'm after next. Let me start with a simple combination, and then we can complicate things. Let me get rid of this here. Okay, so I want to leave the risk-free asset out of the picture at the moment, and I want to form a risky portfolio that has the right combinations of stuff in it so I can find that 1P. And then I'll go back and add the risk-free asset to it again. So I'm going to look at a portfolio that's made up of, let's start slow. Let's start with two stocks, A and B, stock A and B. So I'm leaving risk-free out. I'm going to look at, let's call it stock A. Make sure that I'm consistent with my numbers that I'm going to want to use here in a second so that I don't have to change my mind. Okay. I'll use the numbers that are in question number 2 that's on the online problem. So stock A offers an expected return of 15% and a standard deviation of 25%. This is stock A. And stock B offered a expected return of 6% and a standard deviation of 7%. Okay, stock A and stock B. And now I can put all my money in A, I can put all my money in B, or I can put my money in some combination. 60-40, 70-30, whatever. I cannot go above 100% in A because I can't borrow at this rate. The only rate I can actually borrow at is a borrowing rate, which is the risk-free rate. Okay, so there's no way that I can go beyond, if this was all that's available, I can't go beyond it like I just did a moment ago. Right? I asked you, could I invest 120% in that portfolio? That was only possible if you borrowed. There's no borrowing here. Okay, so if I put 100% of my money in A, I can expect to earn 15% next period. If I put 100% of my money in B, I can expect to earn that next period. Let's define some of these. The weight of A is the proportion of my risky portfolio invested in A. And the weight of B is the proportion that's invested in B. And so if I were to put, and I think this sample said 70% in A and the rest in B, then the weight of A is 70%, the weight of B is 30%, and now, so I'm somewhere between these two, right? I'm somewhere closer to here, a little bit closer to A. My question is, what should I expect to earn on the portfolio? What is the expected return on my portfolio? Well, if 70% of my money can earn that, and the other 30% can earn that, I can figure that out as the average. So it would be the weight of A times the expected return of A plus the weight of B times the expected return of B. 70% of A's expected return, 30% of B's expected return, and the answer is 12.3%, I believe. Okay, so my portfolio, P, should have an expected return of, that's what that is. Now the question is how much risk? How much risk can I expect? I'm going to write this. The risk of the portfolio is not, so pay very close attention to this. Actually, let me stop talking for a second, let you get caught up.
How did you get the weight of A and B?
I just gave it to you. I said that if I'm going to invest 70% of my money in A, and I'm going to invest 30% of my money in B, then I've defined WA and I've just defined WB. Yeah, that's because I'm talking too fast. It's not you, it's me. Okay. So can everybody kind of see this is an average? That's just a simple average. It's a weighted average. This is not an average. This won't work. This is not this. I have a does not equal sign. This will not work. If you do this, you would get 19.6%. It's not that. It's a little bit less than that, depending on how correlated A and B are. It should be a little bit less than that, depending on the level of how closely related, or how. You'll be hard-pressed to find two stocks that move perfectly in tandem with one another, even if they're in the same industry. They're not going to be perfect substitutes for one another. So anything less than perfect movement together, your risk in your portfolio should be less than 19.6%. It should be something less. And here's where the math comes in. That wasn't math, right? That wasn't math. That was like arithmetic. I guess it's still math, but it's not really. It just looks like math because it's got letters. Okay. Here's the actual total risk of the system. So right now I have risk in this system. I've got so this is like a little matrix. When I look at the total amount of risk of a portfolio that has these two stocks in it, there's like three portions of risk. I can kind of divide it up into three things. There's the contribution of risk that came from stock A. So some volatility is because A is volatile. And then there's some contribution to the risk because B is volatile. So there's some contribution from A, and there's some contribution from B. But you might get lucky in that the contribution, they move together as well. And it could be that when A goes up, B goes down. And when B goes up, A goes down. So if all I did was look at the risk of A and the risk of B and add it up, I'm leaving out this notion that they may have a little bit of offsetting going on. We call that covariance. A with B. And then there's the whole system is actually the variance, not standard deviation. So there's A's movement with A. We call that the variance of A. That's the variance of A. That's like the total risk of A. And then there's B's movement with B. We call that the variance of B, right? The variance of B. So there's like the total risk of A and the total risk of B. And then there's some degree to which A and B move together. There's A's movement with B, and then there's also B's movement with A. We call that covariance. And we use this notation, A, B. And we use it here, B, A. A with B and B with A. And if anybody's interested in figuring out how you calculate variance and covariance by hand, let me know and I'll show you, or maybe I'll just put it online or something. It's super simple. It's very simple. It just looks complicated, but it's not. So really what I want to say is the total risk of this system is this. It's the contribution of A proportional to its weight. Right? The weight had something to do with it. And then there's the contribution of B. And then there's twice the covariance. Because AB and BA are the same thing. Let me just define it clear. And you can calculate this in Excel. It's equals COVAR, open paren. And you grab two columns. And you're going to get the covariance of A with B. You'll be doing that because you're going to do the covariance of the stock with the market. You'll calculate the covariance. Now, before I simplify, does that look familiar to anybody in terms of your old algebra? Do you remember completing the square? Do you remember what that looked like? So do you remember something like x plus y quantity squared? Do you remember what that did? You had to, right? So what did you have? You had x squared, y squared, 2xy. That's what I have here. I just have subscripts. Don't you love it? And then do you remember what happened if you had a coefficient on his? Do you remember what happened there? No? Ask your kid. This was supposed to be, right? Huh? Well, remember how this was squared. This became a 4, right? This became a 9, and this was 2 times 3, right? Okay, so do I have that here or what? Right? Okay, so it's really that simple. It's really that simple. So you just completed the square. That's all we've done, is we've said it's all of it. It's all of it. When I put 2 stocks in a portfolio, there's more to the story than just X and just Y. There's this. There's the relationship of X with Y. This matters. That's this. And now here's a simplification that we often do. If you remember your old, you probably don't remember statistics because I wouldn't have if I was in your shoes. But you know how variance is a unit squared. And so we take, it might be something like 396, which is a number that doesn't make sense in like our brains. So we take the square root of that, we scale it down, and we call it standard deviation. We use that number. Now it's a number that makes some sense. Covariance is similar. It's a number that's a unit squared. It's a value that doesn't make sense to people. So they scale it down and they convert it to correlation, which is a number that makes sense to people. And what we have is this. The correlation we often call that rho. That's a rho. I like the face you just made, Caitlin.
Just a little squiggly.
That was I don't know what you're doing, but I'm going to write it down. Okay, so correlation is rho. Rho is equal to the covariance divided by the product of the standard deviations. I'm going to actually, I'm going to use the letters and not the word. Is the covariance of A and B divided by the standard deviation of A times the standard deviation of B. And rho falls between 1 and -1. So if you found 2 stocks with returns that were perfectly positively correlated, rho would be equal to 1. I don't think you'll find 2 stocks like that. I don't even think Coke and Pepsi are like that. And if you find 2 stocks that move perfectly opposite one another, when that one goes up, this one goes down to the same degree, that would be a -1. Correlation would be equal to -1. And again, you're not going to find that either. Right? What you're going to find is correlation somewhere around the 20% level, 0.2. They're not 1. They're not 0. Everything doesn't move like completely independent of one another, but they're not perfectly negative. Now, you might find some that are negative, like they might be in opposite industries or in different countries or something like that. So you might find some negative, but you're not going to find -1. You're not going to find +1. All right. Can you see by substitution that I can substitute something here for the covariance up there? Can everybody see that? I'm going to substitute. I'm going to substitute for this. Right? I'm just going to use my algebra. Everybody with me? Have I lost you on the algebra? Okay? And so here's the trick. If rho is positive 1, this completes the square. And sigma, the total risk of the system is just basically the average of the two. If rho is anything less than that, you no longer can complete the square because this number, when you plug in all these numbers, it's going to be a little bit smaller. It's just going to be a little bit smaller. And you're going to end up with a variance that when you take its square root, it's going to be less than 19.6. So if correlation is anything less than positive 1, you will no longer get this. You'll no longer get that. And so the example I have here is, what if the correlation of returns is 0.5 for this same example that we just did? Now, don't hate me because I'm going to bring it all back together, okay? It's going to be okay for those of you that don't care for the math. It's going to be all right. Okay, let me come over here and start. Shouldn't have done that. Well, you have that written in your notes, right? Okay. So if correlation is 0.5, the expected return of my portfolio hasn't changed because the correlation didn't affect the averaging of the returns. So that still came out to, we said that the weight of A was 70%, the weight of B was 30%. So we still know this. I'm just repeating what we've already done. And we came out with $12.3. But the standard deviation of the portfolio is not equal to 19.6. It's going to be something less. Let's figure it out. Before we can get to that, let's start with the variance and then just take the square root of whatever we get. So weight squared of A. I'll write it first and then I'll plug in numbers. What's the weight squared? 0.7 squared. Sigma squared A. 0.25 squared. Okay, that's the first term. Weight squared of B. 0.3 squared. Sigma squared B. What's the 0.07? Okay, that's the second term. And then twice the weight of A, the weight of B, the standard deviation of A, the standard deviation of B, and the correlation. Shoot, I didn't write down the actual value. If somebody tried to figure that out, you're going to make all kinds of mistakes. If you have it's probably easier in a spreadsheet. If I have a Hewlett Packard, I can do this way faster than you can on an algebraic calculator. That's me being a finance snob. Give me an HP 12C. Does anybody here use the RPN? Huh?
Getting on my
iPhone.
Go tell me again what the P equal 0.5. What's the P in the 0.5?
So this is rho.
A P equals rho. All right. That's what I
That's
thought.
rho. It's not a P.
That's
It's a
what I
Greek
thought.
letter R.
I just wanted to make it look different than yours over there. And I just
It's
wanted to
not
make
as
sure.
curly. It's supposed
I
to be
didn't miss it.
curlier.
Oh. And so you gave us that number.
I gave you that number. It's rho. What number are you getting?
4.44.
What was it?
4.44.
4.44?
Yeah.
I would think it's
Oh, never mind. Missed the decimal. There it is.
0.00444 or something like that. Let me just see if two people get the same answer, and then we'll call it a day. It'll be like trial by jury. Like if I can get to
0.0784.
0.0784.
Better.
That sounds more right, but I don't know if that's right. Take the square root of that. Then I'll know if you're right.
.28.
No, so that's not right. It's whatever it is. Okay. So that is the square root of whatever number you got there.
Will that work on the test?
It will not work on the test. So learn to use an HP 12C. It's going to go way faster. I'll bring mine next time. If somebody could just take 0.186 and square it for me, that's what the number is supposed to be.
We can just use
All right,
Excel,
so when
right?
when we have our last one, we're supposed to take the square root of this.
0.0345.
What was it?
0.0345.
This is 0.0345. And when you square root that, you get this?
Which number do we take the square root?
At 0.0347.
Does that work? So
The square root is 0.106.
Yay, we have a winner. Ladies and gentlemen.
I had it on the H.
You have your HP?
Where did the 186 come from?
No, do you use the RPN? No.
Yes. She had it previously. Oh, that.
Okay. So I would say that the number one error here, because you will not use Excel on a test, but you will use Excel on your project. So even in Excel, people make mistakes because they put parens in the wrong place. They may leave out squares or they put parens in the wrong place. So here's the deal. Because this was not positive 1, this came out to less than 19.6. And the smaller this is, the smaller that is. You're actually eliminating risk. It's actually going away, but yet this stays the same the whole time. So the less and less and less correlated, you have less and less and less risk. And so if you can build a portfolio where the correlations are small, and they don't even have to be that small, they just have to not be 1, you can get yourself down to where you have reduced. You haven't just reduced, you've actually eliminated some of the risk. There's 0.01, there's 1% of risk that's actually no longer in the system, right? It's actually disappeared. Because now the same weights and you've got less. So I think that's enough for one day. Yes?
So basically the next step is we add things to it so we keep making it to where the diversifiable risk is gone or just
It's
like
gone.
the systematic risk.
And all you're left with. So you're never going to be able to, You're never going to get this all the way gone.
That's for the diminishing marginal at that point, right?
Yes.
You're going to reach a point where it doesn't matter if you add another.
It doesn't
one,
matter
it's gonna be
anymore.
there.
And I think many have found that it's somewhere around the 20 stock mark.
So if you're a person who puts these funds together, are you evaluating this on a daily basis as new, as stock prices change, as new, or is there some sort of like, hey, we've done this 10,000 times and this blend of assets in a portfolio
Tends to have this.
Yeah, I mean,
I think they don't do it every day. People don't rebalance every day, but they will keep an eye on it. And what we found is in times of crisis, those correlations that you thought were small or possibly negative, all of a sudden go to 1. So just when you thought you were very well diversified and you had built your portfolio with all these different things in it, and you have managed to reduce your risk as far as you can reduce it, the day that Russia defaults, all of a sudden correlations go to 1.
so the correlations go to 1, which basically means
Everything goes to, everything falls apart. So your correlations are only good, and then what people do then is instead of putting individual stocks, they might put countries in, right? So some percentage in the U.S., some percentage in Europe, some percentage in emerging markets. And what we found is emerging markets are not as highly correlated to developed markets. So you are creating a portfolio doing this. You're intentionally adding commodities. You're adding assets that are not correlated with your main assets. This is the whole point of diversification. You're looking for these correlations, and you're keeping track of them. And then what happens is one country defaults on debt, and all of a sudden all of Europe goes haywire, right? So you can't just do it and forget it. But this is the idea behind a lot of what people do in the investing world. So I've given you in numbers what people really do. They really do keep track of correlations. But you have to be very wise because, in times of crisis, those correlations are not as they were expected to be. Okay? So my recommendation so next time I'm going to stay in this unit. It's going to take me the rest of next class to finish this unit because I want to take us to the CAPM then, which is another step away from what we're doing. I know. Now it's finance, ladies and gentlemen. But I think before then, even though you have your assignment to do, you should look at the in-class practice problems that are already online with their solutions. And what I've done is I've taken this problem and I said, what if the correlation was 1? What if it was 0.5? What if it was 0? Right? What if it's negative 0.5? What if it's negative 1? And I want you to do that, and then I would like to be able to plot those possibilities and see what happens with this trade-off between A and B. And then I'm going to add the risk-free asset back in.
So nothing to submit, just before.
No. This is just like to feel less lost. That would be a way to feel less lost next time. That's all. All right? Thank you very much. Have a good evening. Now that I like.
Fantastic.
Go back to math.
So yeah, hey man.
Now or never.
Yeah, definitely. Yeah.
Hey, Trace, now or
Same
never.
table, same place.
We're already off next week. We're already off next week. We don't have Magnus next week.
We don't?
What?
Huh?
We can,
Class next week?
we have this, but not Magnus. She has a conference or something.
Yeah, I could go 2 weeks without that.
That's why we're just doing the discussion group thing.
Right now?
Yeah.
Let's play hooky.
Maybe this whole side of the room is gone.
We should all just go down the hall and then just see what she does. She'd probably freak out. She's,
And tell her next time. Oh, didn't you get the memo? Oh, wait for it.
I think we should just WebEx in from Kickback Jack.
Yeah.
I got this guy. We can all hook up to it.
She makes you turn the webcam on, though, so I feel like she'd catch on. Like,
couldn't be at the bar.
Technology's not really working well tonight, too. But
Someone's underwear is like, I'm not turning the webcam off. No.
Yeah, what if I was naked?
Look
Sorry.
how I keep my webcam.
Embarrassing.
Control that thing.
That's true.
I'm like,
I heard that.
I have a disease.
Sometimes the camera just.
Oh, I think the laptop's just.
I know, but I have a smartphone, so I feel like I balanced it out.
She's diversified.
I'm just like, well, my feet might get cold, but my upper half will be warm. But I'm willing to take that risk.
I guess so. Diversified in every aspect
Or
of
should
your
we switch it
life.
up?
I don't know, man.
Trey, I bought.
Felt like I was in a groove.
I guess.
Have you ever seen it?
I never watched it.
You never seen it?
I used to have to live and die with them.
I just put like 25%.
Good Lord, what a low-scoring
Oh,
game.
I
It's
don't know
16 and
why.
11. Halfway through the first half.
I did hit like.
kidding
I knew that's
me?
what you were watching.
Yeah, I am. So she was like,
Louisville is 1-2.
I heard someone say something along the lines of,
You're kidding me.
oh, if this is going to be the worst crash ever, and I go, panic! Yes, I'm in!
Yeah, exactly.
Invest. That's the only reason I invest. It's the only reason I jumped in. I took Ross's theory. When he said when clients start calling, that's when it's over. So I heard her talking about it, and we're worried about it, and I was like, I'm in.
Probably.
In.
We had this one in Florida, and he was almost the perfect contrarian market indicator. So he would call in and want to buy something, we're like,
Hey.
and vice versa. It was uncanny.
Oh, this is going to be a different class. We're switching classes.
Yeah.
Switching classes. Hello. How many people were online?
This past class, I have no idea.
Okay. How many were online this past class?
It was a beautiful day.
How many were online just now?
6.
Maybe is.
Oh no. Okay.
You told everybody to be here this week, didn't you?
Yeah, I said, please come.
They must have misunderstood you. We ought to get extra credit.
Yes, exactly. They probably thought, oh, she didn't really mean that. Maybe she'll say, never mind, you guys will just go home.
Do you have the same students coming from last
Usually,
class? Oh, okay.
All
right.
Drive around.
Yeah, I have no use for it. Wait, I guess with it. Yeah, it just sits in my floor.
That would be great. Yeah. So now do the careful over there, you know. Lock your window.
Oh, yeah. We host
Right.
The other thing is I still have not let
I'm good. How are you? You coming tonight?
I don't think it's.
just as easily says. No, I'm just saying. It's like it's just not.
So,
I mean, all the very insane reasons of why it says.
They make when they're typically.
But if my point is it's
they go-
ambiguous either.
They make
Either the
those.
true or the false can be supported.
That's what got it. Give it to you. Here's the thing.
Because I got a 5 out of 5.
Like a tray.
5 out of 5 in the last quiz.
I got one too.
What you doing today?
Trick question.
Got one 5 out of 5. I called Trey. I was like, all right, Trey, I'm about to take the quiz.
I know. This time I actually got 5. Usually I always miss one.
The first one I only got.
The first one you said?
You've only missed one. I've only missed one question. I'm
5 out of 5.
Me too.
4 out of
It's
5.
like-
And 5 out of 5.
This one I got 5 out of 5.
you're
But
not
the rest
missing
of
one.
them, I'm like, I do not.
rolling 100%. I'd like to know what it is.
Yeah,
Me too. I mean,
was it a miss?
All right.
I don't like it.
Flip the coin in one.
I feel like it's totally the way that they're worded. Like, I can obviously comprehend what she's saying.
You gotta be careful.
It. But it's just like, you're just wording things with, like, you're just adding words that are unnecessary. And that's how I feel about the lectures.
Oh yeah, I heard that, and you're like, oh, false, because that's what you said.
Like, adding
True,
extra
the
stuff
way it's
doesn't make
worded
sense.
on that.
That's exactly it. And I think the 2 I've made have been exactly.
I caught myself like that.